Okay, 6.5 is about graphing linear inequalities in two variables. So, a linear inequality in x and y is an inequality that can be written as followed. And as you look at these inequalities, you'll notice that they are written in standard form. So, an ordered pair x and y is a solution of that linear inequality if the inequality is true when those values are placed there. So, let's go ahead and see what this looks like. So, in example 1, we're just going to check these solutions to see if they are a solution to these linear inequalities. So, first of all, 0, 0. If I put 0, 0 into the equation, I'm just going to replace the x value with 0, replace the y value with the y coordinate point, which is also 0 in letter A, and see if that is a true statement that is greater than or equal to negative 2. So we have 0 minus 0, which is still 0, and is 0 greater than or equal to a negative 2? And yes, it is. So this is a solution. Okay, if I look at letter B, and I'm going to do the same thing. The x coordinate point is 0, and the y coordinate point is 1. So I'm going to see if is that greater than or equal to a negative 2. So I have 0 minus 3, that would be a negative 3, and negative 3 is not greater than or equal to negative 2. It appears to the left on a number line, so it is actually less than. So this is not a solution. And if I go ahead and I look at letter C, so letter C, I'm going to replace x with 2. I'm going to replace y with negative 1. Be careful, there's those negatives. I'll even write this one out. 2 times 2 is 4. Negative 3 times a negative 1 is a positive 3. Is 4 plus 3 greater than or equal to negative 2? Well, that would be 7, and yes, 7 is greater than or equal to negative 2. Actually, it's only greater than. So that is a solution. So letter A is a solution, letter B is not, and letter C is a solution. Now let's go ahead and see what that looks like on a graph. So when we graph that equation, I'm going to bring that to the front here a minute, as I have my solutions marked there. Let me just do this. Whoops. I have to select that first. Then I can bring that to the front of my writing so it's not as busy. Okay, so when I look at the graph here then, it says the line is the graph of 2x minus 3y equals negative 2. Now remember, to graph that, you would have to put that into slope-intercept form. When we put it into slope-intercept form, then we would find, then we'd be able to graph it as we have done in Chapter 5. It's a solid line because we have an equal. It's a greater than or equal to. So it is that equation. And then we're going to go ahead and we're going to test a point. And we tested 0, 0. 0, 0, which was letter A, was a solution. So that is part of the solution. And you're going to notice that that part of the graph is shaded. And I'm going to show you the step-by-step ways of graphing an inequality. So step 1, when we graph it, we look at what kind of line we're going to use. Is it going to be dashed because it's either just a greater than or a less than, or is it going to be a solid line because equal is also in the solution? Then when we draw that line, when we're graphing that equation or inequality like we have been doing, we cut our coordinate plane into 2 half planes. Now we need to know which part of that half plane which half plane will include all of the solutions for that inequality. The way we do that is we test a point. The testing point that works the easiest is the origin, or 0, 0. when you substitute 0, 0 in, much like we just did for letter A, if that is in fact a solution, the half plane that contains the origin would then be shaded. So let's see what that looks like. So in example 2, all we're going to do is sketch the graph of x is less than negative 2. Notice that's a less than symbol there. So the first thing we have to think about is we're going to have a dashed line. Now, the other part of this is we only have, for this statement, we only have an x value, so that means it's going to be a vertical line. The vertical line is going to be on negative 2, and so we make a dashed line, because of the less than, on negative 2. Now, we're going to go ahead and we're going to substitute in our origin. So our origin is, right now we only have an x, so I'm going to put 0 in for x. Is 0 less than negative 2? Now 0 is greater than negative 2, so the origin here will not be part of the shaded area. So that means I'm going to shade the half plane on the other side of the solution line. So that is why you see that this part is shaded in. This time we're going to do a statement that is only a y statement. Y is greater than or equal to, so that means the first step is I have a solid line. It's going to be a horizontal line because it is just a y statement. So my horizontal line is going to be located at 1, and it is a solid line because of the equal to. Now I'm going to test 0, 0. 0, 0, the y here is 0, so is 0 less than or equal to 1? Yes, 0 is less than or equal to 1, so that's going to be part of the solution set. So we're going to make sure that the half plane that has 0, 0 in it is the part that is shaded. Now, we need to sketch the graph of x plus y is greater than 3. The first step we need to do for that is to write that into slope-intercept form. So I need to, and this is things we've already done here, I'm going to move my x. So that means I have y is greater than, I'm going to write my x term first to put in slope-intercept form. And now I can locate my y-intercept, which is at 3. And I can see that my line, that my slope is going to be a negative 1. So I can come down 1 and over 1, and that would be my other point to make my line. Now, making my line, I'm going to notice my inequality symbol, which is just a greater than. So I need to make sure that my line is a dashed line. And then my last step, go ahead and substitute back into the original equation. I'm going to write that down here again so you can see what I'm doing. That 0, 0 origin point. So is 0, this is like what I was doing in the first example, is 0 plus 0 greater than 3? Now 0 plus 0 is still 0, and that is not greater than 3. So my origin, or my 0, 0 point, will not be part of the solution. So I'm going to shade the half plane that does not include that point. So I have shaded above my dashed line. So we're going to try to model this with a real life situation. We're going to be on a treasure diving ship that is hunting for gold and silver coins. Objects that are collected by the divers are placed in a wire basket. One of the divers signals you to reel in the basket. It feels as if it contains no more than 50 pounds of material. So you don't know what kind of coins are in there, but you think, oh, this has to be less than 50 pounds. So if each gold coin is 5/10 of an ounce, and each silver coin is 1/4 of an ounce, or 0.25 ounces, what are the different amounts of coins that could be in the basket? Well, the first thing that you should notice in this problem solving is that we have our coins listed in ounces, but we have our estimate in pounds. So the first thing that I'm going to do is I'm going to change my pounds to ounces. There are 16 ounces in each pound, so I'm going to do 16 times 50 to put that into ounces. Just a conversion there real quick. and that would be 800 ounces. So I think in the basket, it feels like there's no more than 800 ounces. So now I have to figure out how I'm going to have all the different solution sets of gold and silver coins. So first of all, I know my gold coins weigh 0.5 or 5/10 of an ounce, but I don't know how many of those I have. So that's going to be my X. I'm going to add my silver coins, and that will be 1/4 of an ounce or 0.25. And that's going to be my, whoops, having some troubles again with the pen wanting to magnify. I'm pressing too hard trying to get that to be more legible, solid lines here. And then it ends up giving me the magnifying. And I know, whoops, so worried about the writing here. I know that that has to be less than, I estimated that it was no more, oh, come on. Right, I'm going to do it with my finger instead. No more than 800 ounces. Oh, this is ridiculous. Okay, no more than 800 ounces. So that's supposed to be a less than or equal to 800 ounces. So now I'm going to go ahead and I'm going to try to graph this. Maybe that will be a little bit easier. So to graph that, I have my equation here, much more legible, typed up here at the top of my screen, and I'm going to graph that equation. So the first thing I'm going to do is I'm going to put it in slope-intercept form. So we're going to make a quick graph by putting in our 0, 0. So I'm going to put what could it be if x is 0, what could it be if y is 0. So when I replace y as 0, I come up with this. You remember quick graphs, that's how we make a quick graph. So I'm going to say x coordinate is 1600 and the y coordinate is 0. So that's this point right here. I'll try to write with my finger again because the pen's not working. Okay, and then if I substitute 0 in for x, my y coordinate will be 3200. Okay, so now I can go ahead and with that quick graph, I can create my line there. It's a solid line because it includes equal to. And then I'm going to test and see if 0, 0 would be part of that. So if I put 0 in for x and y, I would have 0 is less than or equal to 800, which is true. So that means any of these points in this light blue shaded area here, in here, any of those combinations would be true for those coins. So I could read my x coordinate point, and I could say, oh, if I have 800 of them, then I could have all the way up to 1600 silver. If I have 800 gold coins, I go up and I could have 1600 silver coins. And that would be equal to the 800 ounces that I thought was how much the basket weighed. Okay? All right, so that I believe, yes, that concludes our lesson for 6.5.